We'll try to put a link in the description to a video that I made on how to solve most algebra problems using opposites of how when you add something you'd subtract on both sides, when you're multiplying you would divide on both sides in order to get x or a variable to be by itself. When doing that we use Pemdas Backwards. So we learned in school to use parentheses, exponent, multiply, divide, add and subtract when calculating. So we calculate or input numbers using PEMDAS. We do parentheses and exponent, then multiply and divide, then add or subtract, and do those, otherwise our answers can come up different than other people in other parts of the world, but there is a rule and an order. So when we solve, when we're going to solve for a variable, like for example, solve for x, we're going to use PEMDAS backwards, and then we're going to use opposites. So we're going to do add and subtract, then multiply, divide, then parentheses and exponent. And so understanding this will help us in the more advanced math because we use these same principles and these same rules even in the more complicated problems. So we had x plus 2, for example, equals 10, right? We would ask, do we have any addition or subtraction? Yeah, plus 2. So what's the opposite of plus? Minus. So we subtract 2 on both sides in order to keep it balanced and to get x alone. We can multiply, and so we may forget that 2x or 3x or 10x or anything that has a variable next to it and a number, it means times, 2 times x. So the opposite of 2 times x would be to divide both sides, right? The opposite of times is to divide. When we get into exponents, the ones we're dealing with primarily with a radius squared would be squared. So the opposite of squared is good to remember is square root. And you know, in fact, cubed is the opposite is cubed root. Then you begin to learn in Algebra 2 log and natural log. And they have opposites as well. The opposite of log, base 10, is 10. The opposite of natural log base e would be e. So these are the opposites of each other as well. So if you watch that video, you'll get an idea of what I'm talking about because it's a very good system. We're going to follow these rules. I'll do a couple easy ones and we'll be able to do the ones that are more complex, even the ones that look unfamiliar. So again, we use PEMDAS backwards. We ask is there any addition and subtraction, then multiply, divide, then any exponents or parentheses. So when I set up a problem like 2x plus 10 equals 5, or I'll use 4 and make it an even number, right, we're going to see if there any addition or subtraction. Well, yeah, there's an addition, there's a plus 10, we'll do the opposite to both sides. Now we have 2x is negative 6. Now we ask, is there any multiplication or division? There's a 2 times x means we are going to divide both sides. So doing this keeps things balanced and it's the way we solve our variables. We could do this. And we ask, is there any addition or subtraction? Yeah, there's a minus 4, so we'll add 4 to both sides. So we have x over 3 equals 14, and we might not know that x over 3 really means divided by. So we're going to multiply both sides by 3, and that will cancel it out. So we always try to cancel things out to get x alone, and we follow PEMDAS backwards, even when we get to exponents. So let's try one with an exponent, then we'll get into the ones related to radius and circumference. So again, we're going to follow PEMDAS backwards, and we could put 2x squared plus 1 equals, let's say 73. So you might not be familiar with this if you haven't done it in a while, and you might not know what to do first. We ask ourselves, is there any addition or subtraction? So there's a plus 1, we're going to subtract 1 on both sides. And you basically carry everything down. Good mathematicians show their work, they slow down, and they don't try to skip steps. Next we ask, is there any more addition or subtraction? There is not, we go to the next. Are there any multiplication or division steps? And 2x squared means 2 times. So we're going to divide by 2. So like we had mentioned, the opposite of squared is to square root. So now we ask, do we have any exponents? And we do, or parentheses. The exponent here we're going to get rid of by square rooting both sides. Now if we're dealing with a shape, we just say 6 because there's no negative lengths. But really we would typically put plus or minus, right? Because negative 6 times negative 6 is also 36, as well as 6 times 6. So in math it would be plus or minus 6, but in geometry when we're dealing with shapes we would just say 6. So let's get into some of the ones that look different. We'll do some with radius and circumference, and even a couple that are just totally random made up variables. I remember when I got to the variables and they started to look different, it would throw me off. Even when they'd use another letter like a, 2a plus 4 equals 10. I would actually rewrite it to x because it just made me feel more comfortable. But the more we practice, the more comfortable we'll be able to do it in any method we like. So we have some problems where we want you to work backwards. So you're given the circumference of the circle is 2 pi r. And so instead of plugging in your radius and getting your answer, we want you to work backwards. So let's say your circumference is 40 pi. Can you work backwards and find the radius? So we're going to fill in what we know, the c here, we will substitute. So we'll put 40 pi equals the formula, 2 pi r. And that's for our circumference of a circle. So if we're trying to get the variable alone, r, what we're going to do is we're going to ask, is there any addition or subtraction? We're going to go through Pemdas backwards. And you know, a lot of us, we pick this up without realizing that's the order we're following. But as we get into more complicated problems, we're going to always want to remember it because all these problems work the same with the same rules. So is there any addition and subtraction? There is not. So are there any multiplication or division steps? And so again, we're trying to get r alone, so we're looking on that side, and it's 2 pi r, meaning 2 times pi times r. So to get rid of the 2 and the pi, we're going to do the opposite of times. We'll divide by 2. That cancels the 2 out on the right side. We'll divide by pi. And that actually cancels the pi out as well. So it makes it easy. 40 over 2. So we can find the radius is going to be 20. So that's a little bit simple. They can give it to you as a decimal. So let's do another problem here. Maybe they tell you that the circumference is 120. So we would say 120, the circumference, equals 2 pi r, because to get circumference we always use 2 times pi times the radius in a circle. So again, we're going to end up dividing by 2, and then we're dividing by pi. So if I go back and ask the questions, right, we can start over. Are there any addition or subtraction? No. Any multiplication? Yeah. So let's divide by 2. Okay, are there any more multiplication or division? Yeah, there's a 2 times, or a pi times the radius, so divide by pi. Now are there any other steps, any exponents or parentheses? No, so we're done. We're basically just going to use a calculator to divide 120 divided by pi, and then divided by 2 again if you're using a calculator. Unless you have a calculator that lets you write it all the same way it's written here. So let's try one with area. That one's a little trickier because there's an exponent or a square root involved. So let's say that you have the area of a circle we know is pi times r, r squared. So if we give you the area of something and we say, oh, this is 100 pi, find the radius. So we're going to plug in what we're given as an area under A. So 100 pi equals our area formula because we're told that's the area, and that's how we get it, using our area formula. So again, if our goal is to try to get r alone, we want to ask, is there a step with addition or subtraction? Pemdas backwards. And there is not. Are there any multiplication division? Yeah, times. So I'm going to divide both sides by pi because the goal is to get r alone, so we want to move the pi or subtract the pi or divide the pi, whatever is necessary. that cancels it here, but it also cancels it here, pi divided by pi. So r squared is going to equal 100. So do we have any exponents now? And we do. So we're going to square root both sides because the opposite of squared is square root. And we would get plus or minus 10 if we're using regular math, but if we're using geometry, we would just say the radius is 10. So again, you know, we can do another one without the pi if the area is 1,000. So we would say that 1,000 must be equal to the area formula. We're going to see a multiplication times r squared, so we divide. So r squared is 1,000 divided by pi. So what we would do in the calculator is we would take 1,000 divided by pi, but then to get r, there's an exponent, so we have to square root both sides. So the calculator will give you 1,000 divided by pi, and then we square root it. That would be our answer. Let's take a look at how that would be. 1,000 divided by pi. Incidentally, you could push the letter P on your keyboard and it will put in pi when you're using a Mac. I don't know if the Androids work or the PCs work the same way. So that's what we get, and so then the final step is to square root it, 17.84. So here's the goal with this. As you get into Algebra 2, they're going to really stretch you. Right away, they're going to stretch your limits and ability to do problems, and to remember these, but they're also going to start to give you things that don't look as familiar. So let's do something that looks a little bit less familiar. 2ab equals c. And they're going to say solve for a certain variable. It means we want to get that one alone. And we're going to use the same rule. We're going to follow Pemdas backwards. Are there any any addition or subtraction? And no, there is not. Any multiplication? Yes, 2 times a times b. We do the opposite. So we're trying to keep a there, so we're really working to get rid of the ones next to him. So when I divide both sides by 2, that cancels the 2 that's next to the a. If we want, we could write everything over. So again, our goal is to get the a by itself. So do we have any addition or subtraction? No. Any multiplication? Yeah, we do it again. So sometimes when you do this, it's going to be the same as this. Because to divide is the same as multiplying it by 1 over b. So you really get 1 over 2b in the end. So a would be the same as c divided by 2 times b. We can manipulate. This is the beauty of math. It allows you to manipulate and move things around and change them and rearrange them. So if you have one thing, you could find another, and you're not stuck with just one option. So let's do one that's a little bit more complicated than that. We'll add some addition. So I'll just make some stuff up. M times n plus 3 equals p. Just making up variables. So I loved doing this when we were in school because this is kind of like theory. This is saying I know how to use the rules. It doesn't matter what kind of problem I have. So it proves you really understand the theory and the rules behind it. So again, we asked, do we have any addition or subtraction? We need to know what we're solving for. Solve for m. Make m stand alone till we know how much the value is in comparison to the other ones. So we ask, are there any addition and subtraction? There are. We will do that first. So m times n equals p minus 3. We subtracted 3 on both sides, which canceled out that. So we have any exponent or any multiplication or division, and we have a times, so we will divide. So you know when we divide the whole side, so we're dividing everything. So m is going to be the same as p minus 3 over n. So by knowing these rules, it allows you to understand how to solve most algebra problems and even not only solve them, but manipulate and move them around. Let's try one more. We'll even put in a squared. And even fractions and decimals, they're always going to follow these same rules. So let's solve for y. This is a bit challenging. And I wouldn't expect you to know this if this is relatively new to you, but this is kind of showing you where it's heading. You might be really confused by this, but again, opposite of plus is minus, times is divide, squared is square root, and that should be all we need for this problem. So are there any addition or subtractions? And there's a 4, so we're going to subtract 4 if there's a plus 4. And I like to rewrite everything like really you should to stay organized. So 10 minus 4 is 6 because they're both numbers, we can combine them. So now what do? Do we have any multiplication or division? We do. 2 times x times y squared. So I'm trying to get the y by itself. So I want to make sure I do the opposite to the other ones. So the opposite of x times x would be divided by x. And we'll do both steps at the same time. The opposite of times 2 is to divide by 2. So we have the y squared equals 6 over 2x. Now we have an exponent. So the opposite of squared would be to square root it, but we would square root everything. So you would get square root of 6 over 2x. Now if you really are familiar, you wouldn't remember that we're not allowed to have square roots on the bottom of a fraction. I'm sorry. We call that irrationalizing denominator, but let me separate them so you can see. So there's this rule that if they're both under the umbrella of the square root, you can separate them. And so if you were in my class, you probably already learned that you can get rid of the square root on the bottom by multiplying the top and the bottom by that square root. So what that does, square root of 2 times square root of 2 times square root of 2 is normal 2. Square root of x times square root of x is normal x. It turns them into whole numbers and not square roots or whole numbers and variables. And then the top, the rule we have is the numbers can multiply with numbers. So square root of 2 times square root of 6 is square root of 12. And the x is there. And if we really wanted to, right, we can take the square root of 12 is going to be 2 times 2 times 3. So it's going to be really 2 radical 3x stays in there. So this is the kind of stuff you're going to do, and it's really not difficult. I'm sure it looks complicated when you're first doing it, but it follows the basic rules of solving using Pemdas Backwards and always doing the opposite. So there really tends to be less confusion when you start to practice those rules. It doesn't matter what they show you. You can even make up letters and symbols and you can still solve it. For example, I could say 2 spiralies plus, or I could do times 2 spirally squared plus 3 equals triangle, right? We're going to follow the same rules. So do I have any addition or subtraction? I do. So it's going to be triangle minus 3, 2 spiral square squared. So then we have times, so we're going to divide by 2, divide by a spirally thing, cancel those. Right, so our square squared is going to equal triangle minus 3 over 2 spirally thing. And now we have a square, so we will square root both sides. Right, so that's what that little square symbol will equal. And again, it makes you feel really smart when you get to this level, and it's something everyone could learn. It just takes practice. So that's how we would solve the more complicated problems.